LC circuits. The behavior of LC circuits is very similar to that of mass spring systems, i.e., both conform to the equations of simple harmonic motion. These equations are oscillatory, with values going up and down and periodically repeating. That is, they have trig functions in them and are said to be sinusoidal, even though they sometimes have cosine functions. Sine functions and cosine functions are both said to be sinusoidal. As we saw previously, the frequency of an LC circuit is given by this equation right here. Why don't we write the equation for the period of the changes, of the oscillations in an LC circuit? Well, the period is 1 over the frequency. If we took the reciprocal of the left side, then we'd have to do the same thing to the right side, and we'd end up with that. Why don't we do a problem here? Our car radio has a 1.20 nanohenry inductor, and we wish to tune the radio to that frequency. We should adjust the radio circuitry to have what capacitance? We know what F is. F is given, and L is given. There's L right there, and F is given, and we want to figure out what C is. Let's take our equation up here at the top, and let's see if we can solve that for capacitance. Here we go. Let's put the 2 pi on the other side. I'll show a little bit of work here. We'll go 2 pi times F is equal to the square root of 1 over LC. If we square both sides, that gets rid of our square root sign. And then if we solve that for capacitance, capacitance goes in the numerator on the left, and it looks to me like everything else will be in the denominator. You check and make sure, but I think what we end up with is we end up with 1 over, if we square that 2 pi term, it ends up being 4 pi squared, F squared times L. Now, it's just a matter of putting the numbers in and crunching it out. So let's try and do that quickly. 4 pi squared. The frequency is 99.5. Now, we don't want megahertz. We're going to use that little trick where if you have something that has an SI prefix in it, and you know the power of 10 that goes with it, you just take the prefix and you throw it out, and you put the power of 10 right in there. See how slick that was? I threw the mega out because we don't want megahertz, and we put the power of 10, which is 10 to the 6th. And I left the units off because I know those units are right now. We need to square that. And then we're going to do the same thing with the inductor. 1.2 nanohenries. Well, we don't want nanohenries, we want henries. What's the power of 10 that goes with nano? I'm throwing the prefix out, and I'm putting the power of 10 in. That's pretty slick. When you type this in, you end up getting to 3 significant figures, 2.13 times 10 to the negative 9th. And what's the unit for capacitance? Farads. And just like we took a prefix out and put a power of 10 in, you can do the opposite. You can take a power of 10 out and pop a prefix in there. What's the prefix? The SI prefix that goes with 10 to the negative 9th? It's nano. So you could say that if you wanted to.